Good morning, everybody, and thanks for joining us for this week's instalment of the Wood Solutions webinar series. My name's Adam Jones. I'm a structural engineer, part of the Mid-Rise Advisory Partnership, and also host of the Wood Solutions Timber Talks podcast. So in today's webinar, we're looking at timber's lifecycle environmental performance presented by one of Australia's leading experts in this area, Stephen Mitchell from ThinkStep ANZ. So a lot of you are probably familiar with Wood Solutions, but for those who are joining us for the first time, we're a not-for-profit funded by Forest Wood Products Australia. So we're independent and non-commercial. And we basically exist to help people go out there and design with timber products, so in any way we can. And the way we do that is through technical design guides. So we've got currently over 50 of them, going from a range of topics from architectural, engineering, acoustics to costing and so forth. And we've also got the Mid-Rise Advisory Partnership. As you can see on the bottom of the screen here, we've got these different funding partners, and this is the team I'm a part of. So if you're someone who's got a concrete project, for example, that's mid-rise, and you're unsure what the timber solution might look like, you can get in touch with us and we can look at it from a costing point of view, the architectural, acoustics, fire, engineering, and give you some feedback on the feasibility of your project. So after this, I'll give a survey where it'll give you the opportunity to let us know about any projects you might have and would need free assistance with. So a bit of housekeeping for today's webinar. On the bottom left-hand side of the screen, you'll be able to see the chat function. So if you could just change the to field to all panelists and attendees, that way you'll be able to chat with everyone who's joining us with this webinar. So feel free to introduce yourself in the chat and let everyone else know who's here. So good morning, Martin, Damien, Paul, Joseph, Antonio. Thanks for doing that. And we got the question answer on the bottom right-hand side of the screen. So all of these questions, these will be directed at Stephen Mitchell to be answered toward the end of the webinar in the Q&A section. So this webinar will be recorded, and previous webinars have been recorded at this following link on the Wood Solutions website. So I highly recommend you go there, and they're also uploaded to the Wood Solutions YouTube channel. So if you subscribe to us on YouTube, you also get updated and notified when new videos arrive. So we've had some updates to the upcoming topics. So we've got some really exciting ones. Next week is something for the structural engineers, so timber diaphragms and robustness. Following that, we're very, very lucky to have Peter Madison, who is the host of Grand Designs, talking about a really exciting topic on tiny homes, and obviously a lot more coming up. Every Tuesday at 11 a.m, you can expect a new webinar from us. So next week's webinar, so structural engineering topics, we'll be looking at diaphragms, which is a big part of the lateral stability of projects, and then also robustness. So both of these will be covered in the same webinar, robustness being unexpected events. As you can see on the top right here with the car going through a building, that's a bit of an unexpected event that sometimes structural engineers have to find a way to design for. So lucky to have Jeremy Church and Nathan Bembo from VizTech next week. So for this webinar, there will be a formal CPD provided, and it will be sent to everyone joining this webinar in an email sometime later this afternoon. So if you please just check your junk folder. If you haven't received it, it will be in your junk folder or one of your other spam folders or something. And if you please store it in a safe space, as our CPD will not be reissued after this webinar, that would be fantastic. So this week's webinar, we've got Stephen Mitchell talking about timber's lifecycle environmental performance. And some of the learning outcomes we're going to be covering today is you're going to learn what an environmental product declaration is, understand the life cycle of a timber product and the impacts on the environment of your decisions as a designer. So for your CPD, here are the learning outcome questions. What is an EPD? At what stage of a timber's product life cycle is carbon absorbed? And is the proportion of carbon impacts from upfront embodied carbon, which are things like materials, compared to operational carbon, which is things like renewable energy, is that increasing or decreasing with time? So without any further ado, I'll now read the bio and welcome Steve Mitchell, the presenter. So Stephen has over 20 years experience in timber, environmental product declarations, supply chain due diligence for illegal logging and timber waste management and recycling. He He's a principal consultant at ThinkStep ANZ and the current chair of the EPD Australasia. He co-authored 6 EPDs for the Australian timber industry. Stephen is qualified lead auditor for FSC, PEFC, and Responsible Wood Chain of Custody certification and sits on the Green Building Council of Australia's Material and Supply Chain Certification Expert Reference Panel. So, g'day, Steve. I'll currently just stop share.
Oh, good morning, everybody. Thank you very much, Adam, for that introduction. Thank you. Yeah, thanks for that introduction, and good morning, everyone. Thanks, Wood Solutions, for this opportunity to talk about the environmental product declarations and the life cycle environmental performance of timber. So here's my small commercial. I work for ThinkStep. We work across Australia and New Zealand. We've got a range of services for product-based as well as organisational-based, as well as some sustainability software. I'll talk a bit more during the presentation about a couple of things that we've done that will give you an idea of how we might be able to assist you. So today I'll be talking about timber and life cycle thinking, just to give you a bit of an introduction there, as well as what are EPDs and how do we use them, particularly in informing design and construction. I understand we've got some manufacturers, about 20% of manufacturers on the webinar today. So I'll also be talking a bit about manufacturing and how EPDs and life cycle thinking is utilised in that space. So there's a lot to get through. So timber and life cycle thinking. Well, life cycle analysis, life cycle thinking, a few terms there we use are like cradle to grave. So we're looking at the manufacturing right to the end of use, end of life of the product. And we use life cycle thinking. It's like an internationally accepted method of analysis. And we look at it this way so we avoid the shifting burdens. So if to elsewhere in the supply chain. So we might want to save water at the manufacturing stage, and we might increase water usage at the construction stage. So life cycle thinking is a really good way of understanding where those impacts are, as well as avoiding shifts in environmental burdens elsewhere in the life cycle. Now, when we talk about life cycle assessment with EPDs, we look at a whole range of environmental impacts. Now, carbon footprinting, I'll talk a fair bit about that today, or global warming potential, that's the jargon we use in the life cycle assessment community. That's really about the potential impact on climate change. That's the big impact that we measure. But there's also other measures that you really got to think about as well: contribution to water pollution, air pollution in form of acid rain, algal blooms, energy use. It's a really good way of a method of understanding where your energy gets used in your product system, as well as the consumption of water and what stage that's used. So we look at multiple impacts, and again, to highlight any burdens that might get shifted from one area to another. So when we talk about the timber's life cycle, here's the production life cycle. Now, obviously, all our wood comes from trees, which are either grown in native forests or plantations. So we have that forestry process, whether that be natural regrowth or planting in the case of plantations, and then the harvesting process, the replanting. Then we've got the harvesting process. That's all encapsulated in the forestry side of the production process. Then we've got the haulage to the processing mills in the case of sawn timber, kiln drying, might be some dressing, might be some preservative treatment and wrapping, and then obviously it leaves the site. So this is what we encapsulate in life cycle is called cradle to gate. So up till the time it leaves the production site. And then we have all the post-production life cycle stages, like transport to the site, the design and construction process, the use and maintenance of the product, and whether it's used in the refurbishment cycle, as well as encapsulated in that use and maintenance side. And then we have, at the end of the life, 40, 50, 60 years' time, we have deconstruction and demolition processes, and that might lead to a range of end-of-life outcomes, whether it be landfill, reuse or recycling, or energy recovery in the case of some products. So that's really encapsulates the product life cycle stages we're talking about here. More about that later. So what is an EPD? There's yet another acronym, but it stands for Environmental Product Declaration. They're based on international standards. They're independently verified and they're globally recognised. So, in the larger scheme of things, an EPD doesn't represent, a better environmental outcome. It represents the actual environmental impacts of a product. But an EPD does demonstrate a manufacturer's and an industry's commitment to sustainability and transparency. And some big companies and big organisations and associations are coming on board with EPDs in Australia and New Zealand, and that's to be commended. So an EPD quantifies for the end user and the decision maker the impacts across the entire life cycle. Now, here's a couple of important standards that you should be aware of. There's an EN 15804 and an ISO 21930. EN 15804 is basically identical to that updated international standard, but it's important when you're looking at EPDs, we look at these EN 15804 as a standard that an EPD complies with, because that really governs the fair rules about representing the environmental impact of construction products around the world. Now, we've seen a significant growth in EPDs internationally around the world. There's something like over 7,000 EPDs for construction and building products available that are compliant with that standard I just mentioned, EN 15804, publicly available around the world. Our system and where the Wood Solution EPDs are registered with is the EPD Australasia system, which is a partner of the EPD International. And you can sort of see there's something like 1,000 EPDs registered in that EPD International system, of which EPD Australasia is a part, but there's other EPD programs and which add up to about 7,000 EPDs. So when people say to you, I can't get an EPD for a product, well, that's increasingly becoming not true. And as I was saying before, there's some very reputable companies have jumped on with EPDs. With the EPD Australasia program, we've got 31 EPD owners, 62 EPDs literally covering hundreds of products. Obviously timber I'll be talking about in a sec, but also you've got steel, concrete, and alternative steel mesh products, insulation, galvanizing of steel. We've even got down a rail. I've actually done an EPD we've done an EPD to them for the whole rail carriage for the Northwest Rail Link in Sydney. So you can get from very simple products to very complex products, you can get the environmental impact data. So with the Australian timber sector EPDs, what we've got covered there is the 6 main product groups there: sawn softwood, sawn hardwood, particle board, MDF, plywood, glulam, softwood and hardwood, and soon we're just working on a sawn cypress timber, Australian cypress timber EPD, and that'll be out soon. We're just finalising the data, I think, this week. We're also developing EPDs for companies themselves. So we'll have an EPD we're developing with XLAM in Australia for their radiata-based CLT produced in Australia. New Zealand timber industry, we import quite a lot of New Zealand timber, sawn and finger jointed radiata. They've also got an EPD registered with the EPD Australasia program there, so that's publicly available. And speaking of EPDs that were associated with the International EPD program, they've got their own database. They've got something like 47 wood and wood-based EPDs, including for Swedish wood. I've got a Swedish Wood Association, got an EPD for sawn softwood that we import. XLAM, you see there in Italy, have got an EPD there for Stora Enso. We've got an EPD for their CLT products there. So all widely available, publicly available through the International EPD website. So I just wanted to highlight a couple of points about how you read an EPD, just some simple things. It's important that you look at the, when you're looking at the cover, we're looking at the compliance with EN 15804, very important in the construction and building product space that it's compliant with that. It's also compliant with this ISO standard, but it's very important that they comply with EN 15804. So any comparisons that you do, and these feed into whole of building life cycle assessments for assessing the impact of a whole building. Geographic scope, date, etc. The program operator here, a reputable program operator here. We've produced this one in particular. They've been independently verified. So this is what we do as ThinkStep. This is our bread and butter. You can develop them yourself. Other companies have done this internally, but you do need them, or they all do need to be independently verified. You'll always see this at the front of an EPD, which life cycle stage is being represented in the EPD. You'll see here this production stage. They all have to cover that. That's an X. I'm trying to get this changed to a tick, make it a bit more positive. But at the moment, it's they include the next. So the data that's included in the EPD covers that raw material, transport, and manufacturing stage of production. Some EPDs include construction stage information, and some the use stage. Most EPDs also include data like the Wood Solutions EPDs. They include data on the waste side of things, the disposal, as well as reuse and recycling options. So that's important to understand what that data is included. So I've grabbed a couple of bits out from the glulam EPD to show you. This is the information there on the carbon footprint, or the embodied carbon of production. So when we're looking at timber, we're looking at an overall negative number. This number here, global warming potential for fossil fuels, is the emissions from fossil burning diesel or electricity that uses coal. That's the impact from fossil fuel. The minus number here, biogenic carbon, that documents the amount of CO2 that was absorbed by the tree during its long growing stage, and these are just this total here is a function of those two. So, adding a positive number to a negative number, when we in the scheme of things for timber, we always end up with a negative number. So this is the softwood glulam. The number on the right here is the overall figure for hardwood glulam. So this is breaks that down a bit. Now, these are figures for sawn softwood, so they don't correlate to the number I just showed you, but you'll see there's a big overall negative number. So forestry, to answer one of the EPD, or one of the questions, EPD questions, during the period of growth, whether that be 25 or 30 years, it's absorbed CO2 of about 900 kilos of CO2 is sequestered by the wood. And the harvesting and planting operations, they per cubic metre, this figures are, by the way. This is all based on per cubic metre of softwood. There's 42 kilos of CO2 released at that stage. 7 kilos for haulage, 34 for processing, 87 kilos of CO2 equivalent released during kiln drying, 29 for planing. In the case of softwood, H2F treatment adds a small quantity, and wrapping pretty small there. And at end of life in a landfill, there's only a small release of carbon at that stage as well. So you add all these numbers together and you get a big negative number in the order of minus 600 kilos per cubic metre. For hardwood, we've done the numbers for hardwood as well. Much denser timber, longer growing, so you get much more CO2 sequestered in the wood. There is a larger footprint from the forestry processes in the case of hardwood, larger area during its harvested, not quite as efficient a process, and also roading and some hazard reduction processes that impact on those numbers for forestry for native hardwood. But still, it's relative to the total number sequestered. It's relatively small. Again, we get some emissions from harvesting, processing, planing, some from treatment if the timber gets treated, and again at end of life there's a small emission there. But again, it's around about 650 kilos per CO2 across the whole of the life cycle. So sort of big negative numbers, if that's the correct term. And we can convert those numbers for cubic meters to things like hardwood, which is sort of sold on a square meter basis, hardwood flooring, sorry, which is sold on a square meter basis. We can just convert that into, say, 12 mil flooring, convert that on a volume basis, and you get a number of -8 for 12 mil flooring and -12 for the 19 mil flooring. So you can sort of see how you can use that information into more detailed products. So how do we compare then environmental performance of timber? I mean, performance is everything in the building game. We talk about performance of stress grades, hardness grades, durability. Now, timber environmental performance shouldn't be any different. We can use the EPD documents the environmental performance of products like timber, and we can use that to compare and use that data in our own comparisons with other products. Now, because they're produced to those same category rules, that's why that, again, why that EN 15804 compliance is very important. We should compare equivalent function and within the building context. Just a word of warning, particularly to say manufacturers out there, if you do want to make public claims, you just got to be careful. Come and see us if you want to make some public claims, because there's a process that you should really follow so you don't fall foul of ACCC or fair trading rules. We have done carbon calculators for companies in New Zealand, for example, Naylor Taylor, for carbon calculators, compare timber with other products. So come and talk to us if you want to do a comparison. Now, here's how not to do a comparison, okay? You're comparing 1 kilogram of steel with 1 kilogram of concrete with 1 kilogram of timber. Sure, you get nice numbers for timber, -1 with the stored carbon we talked about, but don't do this, because you don't use 1 kilo of timber in place of 1 kilo of concrete. Obviously, they're quite different proportions that you will use these in your product. So don't do it that way. Here's a better way of comparing, say, different products, is you're comparing functionally equivalent products. So in the term of structural steel, universal beam over 1 metre is this equivalent reinforced concrete beam, and here's the equivalent glulam timber beam. So this is a very simple comparison that you can do using the EPDs for structural steel, or using the EPDs for reinforced concrete, and using the EPDs for glulam timber. So you can do that on a product basis. And as I was saying before, with the timber flooring example, where we've got that -8, -12, you can sort of see the comparison with a 3 mil UK vinyl flooring product. There's a real saving in using the timber product. So again, these EPDs, EN 15804 compliant, so you can, provided they're functionally equivalent products, you can use those information from those EPDs to make those comparisons. But a better way, as I was just describing before, is to use EPDs to inform your design and building in a whole of building context. So you're using all those EPDs for the different products. There is another European standard, EN 15978, which actually codifies how that gets done. And the EPDs that comply with EN 15804, they feed directly into that process for that whole of building life cycle assessment. So you use software like we provide, called Gabi LCA software. There's other tools out there. Some companies use that software themselves. We're a specialist in that space as well. We can do those comparisons and assessments for you. But here's one of our clients, Lend Lease. They utilize. They've got. They do their own LCA. They've got their own LCA capability, and they're one of the big users of timber in their commercials buildings. Recently, in the 25 King Street in Brisbane site, so you can sort of see there that they've used that to document the life cycle outcome of using timber products, as well as a lot of other improvements over their standard reference building, and done a life cycle assessment based on life cycle assessment methodology. So you can sort of see here on the global warming potential of the whole building, cradle to site, using the materials, construction activities, operation and maintenance, and end of life. So you get a whole of 60-year total over for the reference building the building they actually built. And they've done some comparisons with their reference building here. I think they've done about 50 LCAs for mainly for the Green Star rating systems, but they do it themselves internally to improve and measure what they've done and benchmark what they've done and how they can improve. Here's a great roadmap that they use when they're planning their jobs, and they're really looking at embodied carbon as an issue. As energy efficiency of buildings, commercial buildings, improves, the proportion of emissions that come from the embodied or products impacts increases. That's the answer to question 3 in the CPD. So this is why companies like ThinkStep and why the Green Building Council, companies like Lend-Lease are focusing on embodied carbon, and this is why it's going to be an increasing focus of the organisation like Green Building Council of Australia. So they use a range of strategies, not just use substituting materials. They actually dematerialise. For the engineers out there, there's a lot of work involved in reducing the amount of materials that they use, and steel industry is working in that space as well. And there's also strategies around alternative materials, and there's also strategies around procurement. So it's a multi-level strategy that Lend-Lease uses, and some of them make the cut, some of them don't. Some of them make a high impact, some of them pretty neutral. So this is the assessment process that they go through. And here's an example how they're using that at Barangaroo South. Their target is to reduce the embodied carbon footprint by 20% compared to their typical designs. And in the case of one building there, International House, which no doubt many of you have seen, they have made a massive 1% reduction in their embodied carbon footprint of that building compared to their standard reference building, and that's also led to significant life cycle costs saving. So it's not all altruistic, save the world stuff. It's actually leading to real cost savings. We do the peer review of these life cycle assessments, by the way. That's one service that we also help Lend-Lease with. So if you've got some projects that you want to do this on, please come and talk to us. So there's not only those whole of building assessments that EPDs contribute to and help drive improvement. They also help drive improvement in the production side of things. So when we're talking here about the life cycle of, say, sawn softwood, I talked about before, we looked at the kiln drying process, and there's this 87% kilos of CO2 emitted per cubic metre of sawn softwood processed. Obviously, that's one of the biggest impacts in the life cycle there. And this is an area where, say, the Australian softwood industry is measuring and making improvements, and they're making big improvements by targeting this hotspot. So companies like Wespine, Timberlink, AKD Softwords, other companies, they're improving their kiln drying process. A lot of them using installing rotary kilns, which are much more efficient in terms of energy efficiency, and hence less natural gas being used, less wood residue being used. So you make a saving in costs as well as savings in emissions reductions. We've actually measured this over the last 10-year period. When we did the EPDs, updated them in 2015-16, we found a massive 12% reduction in the carbon footprint of manufactured Australian softwood. There was a 6% improvement in the Australian hardwood global carbon footprint of Australian hardwood over the similar period. So that's another good use of EPDs, and the life cycle assessment that goes in behind them is understanding what improvements are being made in terms of the carbon footprint. So you can't rest on your laurels. Sure, you got a nice negative number there, but you also want to drive improvement in the manufacturing sector. So those improvements came about from better recovery rates, from decreased energy in kilns, from in the case of MDF and particle board, there's a reduced resin loadings in those products that can make a significant difference. There's an increased substitute of natural gas with biomass residues, using those as fuel. And in the case of veneer and plywood products, there was just less energy used per cubic metre. So that's the improvements we found over that 10-year period. And the process of developing the EPDs also led us to find some opportunities in the forestry side of things. If some alternative use can be found for some of these harvest residues, that will result in a better profile at the forestry stage. Improving resource recovery for sawn, so getting more out of the log. A lot of manufacturers these days are using finger jointing or cross-laminating sort of processes to get more recovery from the log itself, so there's less residues produced. Driving further kiln drying efficiencies and moving away from biomass to biomass from natural gas. So that's another opportunity there which the industry is acting on, as well as this great photograph here. If this is from Nataris up at Grafton, and the similar sawmills around Australia that are increasing their renewable energy use by putting panels on their roof and managing that to run the machinery during the day. Okay, obviously as the grid gets greener, hopefully that will contribute to a lower profile. It helps all manufacturers, but putting solar panels on your roof helps your individual manufacturers reducing their carbon footprint. So some conclusions then from this presentation for you. I really like EPDs, and I think the industry recognises that they're now a good product for them, a good way of measuring and what they do. As specifiers, most of you are specifiers, architects, engineers, and the like. Well, asking for an EPD can be a very important thing that you can do, because you're asking the supplier to measure and track their environmental impacts of production. Okay, some producers do that off their own bat. Many need a bit of a push, so that's something that you can do to help them understand and reduce their impact. That data is analysed, it's verified, it's for the whole product life cycle, so you can understand where those trade-offs might be and reduce the likely likelihood of just making a problem somewhere else. And obviously manufacturers can invest this confidence and reduce their costs if they can understand where there are inefficiencies or impacts in their system. So I encourage you to ask for EPDs, use the verified data to improve your design and building process, do your bit to reduce the impact of your process, your design and building process today. Here's a lovely endorsement from Davina Rooney at the Green Building Council. They recognise the role that EPDs have to play in Green Star rated buildings and the wider Australian built environment. They have a transformative effect in some sectors. There's similar feedback with the Infrastructure Sustainability Council of Australia. They have a rating tool called the IS rating tool. And that's a really big driver for other building materials. Not so much timber, because there's not much timber used in infrastructure space, short of formwork. But that's a big driver for the concrete and steel industries, and a whole heap of other industries to go down this EPD route because of the infrastructure sustainability requirements ratings tool, which performs a similar role that Green Star does in the commercial building space in Australia. So here's a few of our clients. We can't use Lendlease's logo, unfortunately, but we've got some very reputable clients here in Australia and New Zealand. Be happy to talk to you about how we can help you if you're a building materials supplier, or you're an architect or an engineer understanding the impacts of a particular project. Please come and talk to us. Okay, there's my contact details. I'm happy to answer some questions now. Thanks, Adam.
Thank you, Steve. Appreciate it. That was fantastic. If you could just, I might just share my screen. I'll take it from you. There we go. Okay, so we've got a few questions in the Q&A tab here coming through. So thanks for everyone who's asked. We've got one question here from Blake Vanbrook. He says, if there is 900 kilograms of CO2 sequestered in a meters cubed of softwood at 550 kilograms per meters cubed, what happens to the remaining 350 kilogram per meters cubed of production? If there is only 50 kilograms at the end of life, what is your assumption about the timber? So I guess the crux of that is at the end of life, we're still sequestering carbon. Can you just talk a little bit on what might happen in maybe a few of the different scenarios?
Yeah, so the end of life as staged, yeah. So the tree absorbs that carbon dioxide during its growth, and that carbon, 50% of the dry weight of wood is carbon that's taken from that CO2. So that sits in the wood for its during the production and during its use. And then 50, 60 years down the track, when it might get demolished, extracted, one of the routes that it could follow is into landfill. And there is some very good, and that number that we got there, about 56, I think, kilos CO2. There is some impact from transporting it to landfill and some processes around there. But a really good researcher who's recognised with the IPCC, Fabiano Jimenez, has done a lot of work on understanding what the impact of timber in landfill is, and he has shown that for the most part it just sits there. Okay, so that carbon embodied in the wood just sits there for decades, for the long term. So, and provided those conditions don't change, someone digs it up and introduces oxygen into the landfill, that will just sit there. So that explains the very small impact of putting wood in landfill. When it goes to reuse and recycling, the life cycle, how that gets treated in life cycle assessment is a bit more complicated, but the carbon still sits with the wood. Obviously the wood, might get transported to the recycler, maybe redressed and sent out again, so that carbon just stays in the wood, so it just gets an extra life as in a reuse. A lot of wood now is getting recycled into particle board. Okay, so that carbon again just sticks with the wood fibre and goes into another long-term use into a particle board product. Yeah, I think that answers that question, Adam.
Yeah, no, that was perfect. I've got another question here from Jane Armstrong. G'day, Jane. Hope you're well. Are there any comparisons for overseas engineered timber? The haulage would be considered as boat transport. So I'm not sure, Steve, if you've had a look at doing EPDs for international imported timber, and if you can speak to a bit of the shippage and how much that might offset the carbon positive.
No, it's a really good question, because we import a lot of timber, and as I was pointed out before, there are EPDs for a lot of imported timber products now, so we know what the numbers are. When Lendlease did that project in Melbourne, they did a life cycle assessment, because that CLT, where was that in the harbour there? or next to the harbour, sorry. They did a
International.
life cycle assessment, of that project, and that timber was coming from Austria via Slovenia, and I think from memory it added about 100 kilos per cubic metre, the transport, which in the scheme of things, sure, it's significant, but you still end up with a negative number because you can fit a lot of timber product on a ship, and it's a pretty efficient way of getting stuff around. Okay, you can. So it's often, transport is often raised as an issue. It can be significant if you're using diesel trucks over a really long period, really long. But shipping generally doesn't add that much, as packaging doesn't make much difference either, or preservative treatment. Okay.
Thanks, Steve. We've got an interesting question here from Celia Johnston. She asked if you can recap the basic percentages of upfront operational carbon. So for those listening, that's all your energy versus your upfront carbon, which is from your material impacts and everything that happens before the operational phase. And you mentioned this is a bit of a moving beast as it's changing going forward. So maybe if you can talk about, if you know any percentages off the top of your head, what it previously is and where it might be tracking the proportion of impact from the materials.
Yeah. Well, the proportion of say embodied carbon from materials compared to the operational carbon usage really varies depending on the building type. It's fair to say that there's some really good research to show that buildings are becoming a lot more energy efficient, so the proportion of emissions that come from the building materials that are used in a project is rising. Okay, so the figure that's generally banded around is 18%. So 18% of the emissions come from embodied carbon, the material side of things, and the rest come from energy usage to heat and cool a building. That's the figure that gets used a lot. That tends to be based on research in colder climates, like in Europe and North America, where a lot of this research is done. We commissioned, when I was with the Timber Development Association and FWPA, commissioned some research from RMIT in Melbourne on a housing type array, just basic housing, and to answer that, to find out some details on that question. And they found, interestingly, that in mild climates like in Sydney and Brisbane, where you don't use as much energy to heat or cool a building, the materials, the embodied carbon from the materials can be up to 50% of the impact over, and that's accounting over a 50-year life of a house. So it can be very, very significant currently. Okay, in mild climates, the embodied carbon impacts can actually match, or if not, be bigger than the embodied carbon emissions. So, and that will increase over time as buildings, commercial buildings in particular, become more and more energy efficient. The proportion will increase over time unless they're addressed like we're doing here today.
Yeah, and I saw in 2019 the National Construction Code updated Section J, so requirements for energy efficiency. So as the energy efficiency and we build better quality buildings with better facades and passive house and things like this, the operational carbon problems getting solved. And then obviously the next one that's left over is materials, like you were saying. Just on that, Steve, have you seen that being reflected on, you said you're on the panel for some Green Building Council workshops for their new Future Focus tool. Do you see the general trend toward more interest and focus on materials in general going forward? Yeah, and there's been a bit of a focus, but it's also always seen as a bit too hard. But with these EPDs, where you've got verified information and verified data, it's becoming much easier for people to address it and quantify the improvements. So it is
with their involvement with the Green Building Council and their their supply chain materials group, they're starting to embed these EPDs in decision in the tool, and the next iteration of the tool will recognise that. I got to say as well. I mean, I have involvement with the steel industry and the concrete industry as well through my role in the EPD program, and they're not standing still. Okay, there's making the steel industry is reducing their carbon footprint of some of their products by dematerialisation, by improvements at the manufacturing level. They're also using EPDs to drive improvements at the manufacturing level. Concrete industry with alternative cementitious materials and geopolymers. So they can see the writing on the wall as well, that this is becoming increasingly an issue, that they're getting requests from their customers, whether they be infrastructure designers, government entities, everyday designers and builders on projects. It's definitely becoming more of a focus for them, and it's becoming easier to address it.
Mm-hmm. Absolutely. Got a question here from Esther Allen Howard. She asked, how's the impact of deforestation been taken into account in regards to environmental impact? So can you talk about that side of things? And
Yeah. No, it's a really good point. I'm glad you brought it up, because I'm an FSC, PFC chain of custody auditor. So a lot of that carbon work that we do, and it's mentioned in it's described in the EPD for the Wood Solutions Timber EPDs, is on the proviso that it's FSC or PFC or responsibly wood service certified material, or it comes from a sustainably managed forest. And in the timber industry, that we've got that sustainability certification systems of FSC, PFC, responsible wood. So that's a third party saying that this wood supply chain is being well managed, sustainably managed. So not all wood is good, right? From a carbon perspective, if you're hoeing into a rainforest in whether it be PNG or other parts, other neighbours, you've got to ensure that the wood you're buying is sustainably managed. So those carbon footprints only apply in those circumstances. So there's two parts of that. For the wood, you've got the source certification, and then you've got the manufacturing performance. Okay, so you've got to look at wood in both those spheres, and that's recognised in the next iteration of Green Building Council, that they'll more deeply embed that FSC and PFC requirement in the requirements for wood going forward.
And I might just tack to that. So in Australia, we're net reforestation, from what I understand. So we've got a very ready industry and doing things in the right way. And there's some parts of the world where it is net, deforestation. So as you said, there's most products in Australia are certified. I think it's pretty much across the board, certified sustainably. And if it's being regrown, it really truly is renewable material. But if you chop it and then replace it with another thing like animal agriculture or something, that's the only time deforestation comes into it. So as long as you're replanting at the right rate, then it's not deforestation.
Yeah, I mean we think in the forestry side of things, you think over the whole landscape. It's sure, the trees get cut down in one area, they're regrowing in 49 other areas at the same time. Yeah. So you've got to think in a landscape sense with the wood side on the wood sourcing.
Okay, so have you got the questions up as well, Steve? I might let you. A couple.
Okay.
I've got a question here as you're looking from Luca Brown. At what size of project does it seem viable, useful to do a life cycle assessment? For example, does it seem reasonable to encourage residential clients to consider the impact of product selection?
Okay, there's two parts to that question. Is it reasonable to do a life cycle assessment? No, I wouldn't do it on every project, that's for sure. And companies like Lend-Lease don't do it on every project. You can do but they're learning as they go. So this has been a learning tool for them, and they can start to reduce the number of life cycle assessments they do because they know uh, what they've learned from previous experience. But you can do a scoping LCA, so it's just using some general figures about this, and this is often how in the design process it informs the design, and that's probably where it's most useful is informing the design. So you do a scoping LCA. Where are the big wins? Where are the hot spots? Much as that chart I showed you that Lend-Lease do. Okay, where are the potential big wins? And we'll focus on that. Okay, and then you might do a life cycle assessment once you've bedded that down to get to the nitty gritty to see and to people also use that to get Green Star points because Green Star rewards that process. Okay, and then you can use that detailed life cycle assessment to really understand where you've made significant improvements and to get credit for that through the Green Star or ISCA rating system. So with residential buildings, on a case-by-case basis, there's no way you'd do that. But, I mean, there are some very simplified tools out there that can do that. But if I was a project home builder and, pumping these out, yeah, I'd use them on the whole, on some of their products for sure.
And Steve, you might speak to this a bit more, but I think I saw the Green Building Council recently released Green Star for, forget the exact wording, but for residential projects. So, Green Star are moving into that residential space, and they're also putting together that carbon calculator, which is going to be part of all projects, which is, it's not going to be a perfect detailed and get everything exactly right to the level an LCA will, but as you said, the very high level, quick assumptions based on what the impacts and materials will be.
Yeah, that's right. That's and in New Zealand as well, where we do work in as well, the Green Building Council tool over there recognises EPDs and incorporates that. So it'd be interesting to see what take up that residential Green Star gets. I can imagine some big developments might take that up. So it's really good. I mean, I call the Green Star rating tool like the voluntary building code, if you like, and the people get used to ideas on a voluntary basis and increase capacity to understand what's going on and how they can make improvements. And they do it on a voluntary basis and then that hopefully informs regulation down the track, because obviously National Construction Code is where the big game is at with the residential sector. But they're a very conservative organisation. They want, rural data, real information to drive improvements. So I can sort of see this embodied carbon and EPDs eventually finding their way into the National Construction Code. But, you have to have the information there to prove your case. So I think that's the way it's going.
Absolutely. Thank you so much, Steve. If we might have one last question before we wrap it up. Is there anything that you can see in the tab that you'd like to speak to?
There's a question here. Briefly, there's a hybrid approach from Chris Bunton on to LCA impacts as used in the EPIC database developed at Melbourne Uni. There's a couple of different approaches to LCA, and EPDs are our preferred approach to doing that. The EPIC database uses an economic-based approach, which is okay for like scoping out maybe some big picture items. But I'm not a big fan of the timber data that they've produced there. I don't think it's quite right. So just a note of caution there on using that. I'm sure some of the other data might be applicable for other materials, might be really good, but for timber, people really struggle with timber sometimes in the life cycle assessment because of that biogenic carbon take up, and they get a bit confused. I'm not saying that they got confused, but that's why the data in EPDs, which is developed to international standards, and they're pretty strong and proven standards now. That's why I think you've got to rely on that sort of information for any scoping LCAs that you do. And any detailed design. So I just want to pick up on that point. I love anonymous attendees. Why do they still use global warming potential instead of changing the term to climate change? Well, yeah, I don't know. That's a good question. If I was a marketer and like marketing LCA all over again, I'd change it to climate change tomorrow. But anyway, that's the one. It is what it is. That's the term that the IPCC still use as well, by the way. Global warming potential, International Panel of Climate Change. So we're trying to be scientifically based, if you like, and base that all on, good scientific information and methodologies.
Fantastic. Thank you so much, Steve. We might leave it there. So thank you so much for your time this morning. And that was really informative. And I'm sure everyone watching right now really appreciates it. And everyone, we can't hear your applause. So feel free to, in chat, just say thanks to Steve if you like.
Thanks very much, Adam. Appreciate your time and the occasional talk. Okay, thanks, everybody.
Okay, thanks everybody. I hope you enjoyed that webinar with Stephen Mitchell. Just before we go, just a quick plug for the Wood Solutions Timber Talks podcast. On your screen here, it's some of Australia's case studies we've looked at, and also world-leading projects like Ho Vienna, which is the world's tallest timber building. And on these, we get the project team together, and you can sit like a fly on the wall and listen to some of their conversations. Also in season 3, which was released about 6 weeks ago, these are some of the guests. A few of these people might be familiar, as including Stephen Mitchell in the middle here, as they were on the podcast also. So just a reminder, next week's topic is going to be great for all the structural engineers and everybody else who's got some curiosity about that, on diaphragms and robustness with Jeremy Church and Nathan Benbow from BizTech. So thank you very much again for your time, and I look forward to seeing you next week.